several students asked me questions about a SQL query in our first homework assignment. Yeah, let me answer, a few questions. First, two students asked me how to access the database. Yeah, actually in class, I show you. Yeah, all right. So I send them the link. Yeah. To get that, first, you need to go to W3 School. Yeah. Website, W3 School. But when you get there, you need to click this MySQL tab first. MySQL, okay? Not a SQL. Yeah, because some students may click, there is a SQL tab. SQL. Yeah, SQL. Right, whatever, yeah, but just the yeah, that one. Right, the fourth one. Do not click that one, okay? Yeah, yeah, because our MySQL version, there are some special properties. Yeah, if you go to the SQL session, you don't have those properties, okay? So we have to go to the right tab, MySQL, special properties. After that, this, try it yourself. Yeah, you can access the database. You click this, you can access the database. Here. Then this window, you type SQL command. Okay, you type SQL command here. Then you click Run SQL, you see the result. Yeah. So that's the first question. Yeah.
Oh. Thank you. That answers my question. I was trying to do the SQL instead of the MySQL.
Oh, SQL. Oh, that's why. Oh, good. Yeah.
Now it works.
It works. Oh, super. Oh, wow. That's a great experience. Yeah. Yeah. I couldn't connect it. Yeah, I couldn't connect, but you click SQL. Oh, yes. Andy.
I'm sorry. Could you show me how you get there again?
All right. Yeah. Yeah. The second time, although it's recorded, first we go to W3 School. That's easy, right? When you go to W3, you find this MySQL tab. All right. Don't go to SQL tab. Okay, SQL. Go to MySQL tab. Yeah. The reason is we need special properties for MySQL. Yeah. SQL because it's a common denominator, things like that. But if it's not common, SQL section does not include. Common for all the DBMS. That's the SQL. But if it's not common, then SQL does not include. All right. So, oh, good. Yeah, that's a great way. Yeah. Yeah. Okay. Yeah. Okay. That solves it. Yeah. So because I didn't realize, so now you told me that. Okay. Yeah. So that solved the first part. Yeah, but some students, I feel, they may not follow the video closely. Yeah, although I talk about that in the video, but some students didn't watch the video. Yeah, it happens. Yeah, I just post the link. Okay. Yeah. When we get to the right page. Yeah. So here. Oh, we're already here. Yeah. This one. This is the Oh. Yeah. We click. Try it yourself. Yeah. I just copied this link. Post in announcement. Okay. So those students just click the link. Yeah. So you get there. Yeah. After class, I will post it. Yeah. Okay. Yeah. All right. So that solved that SQL. So you can do hands-on practice. Yeah. So that's great. Then I don't worry about the Mac machine or Windows machine. Yeah. It's not your Mac machine problem.
Yeah.
Yeah. It's the. Oh yeah. Yeah. I didn't realize that. Yes. Yeah. Yeah. Very good. Yeah. Okay, we fixed this important problem. All right, that's the first one. Now we move to, we have a few topics left from part B. Yeah. Yeah. Last one or two slides, I think. Part B, yeah, just a minute. C. Yeah. All of them. Yeah. I need to go to part B. Yeah. Yeah. As I remember, we have, yeah, so we just, yeah, this null value. But I need to explain that. Yeah, actually, we have many slides left. Wow. Yeah. It's a, you know, things like a long story. Anyway, yeah, we need to complete it because it's important. Yeah, so now we need to understand this very important value, this null value thing in SQL. All right, what is the null value? First, we need to understand why we need to use the special value. Because in the business, so if you connect to your real world practice in business, you may have some very complicated situations you need to handle. Yeah, so null is used to represent a missing value. Yeah. Because sometimes some value you do not know, right? When people do the data entry, yeah. So one or two missing values. So how do you handle that missing value, right? Yeah. That's very common, okay? Missing value, all right? But that it usually has one of the three different interpretations. Yeah, because when you have missing value, the underlying meaning could be different. You may have different reasons to have missing values. Yeah. Here, we just see three of the common missing values. But you may have other missing values. You may have other reasons. Yeah. All right. First one, unknown value exists but not known. Yeah. So exists. You can figure it out. You can figure it out later sometime, but just at current time, you don't know it. Yeah, that's the first common case. Second, unavailable or withheld value exists but is purposely withheld. Yeah, that's another case. Yeah. So it exists. It's available. It's available somewhere in the company. Some place, but due to some reason, so probably some secret or some sensitive information people do not want to put there. Okay, yeah, because the real world situation could be very complicated. Here are just a few examples. So you may have 10 something different cases, right? Yeah. The third one, not applicable attribute. The attribute is undefined for this tuple. Yeah. Available, right? Yeah. Yeah, I mean, yeah, n/a, things like that. Yeah. Things like that, okay? Yeah. Not applicable, right? Yeah. Yeah. All right. But there could be more cases, yeah. But here just some special reason. Yeah. So you do not have the concrete value to place there. In that case, let's consider what's the best way to, because you need to put something there anyway, right? Yeah. You need to put something there anyway. So which way is the best in this situation? Here we want to answer that question. Which way is the best? Yeah. So here we can consider a few ways. Yeah. All right. So let me show you. One way, can we leave that field empty? That's one way, right? Yeah. If you leave that field empty, that means you take the string value empty. Yeah. Single quote around nothing. That's empty string, right? Yeah. So here, because one student asked me how to represent space character. Space character, single quote around one space character. Okay? One space character. But here, single quotes around nothing, that's the empty string. Okay? Yeah? They're different. They're different. So that is one way people can use empty string, right? Yeah. You know, special value put there. Yeah. And, you know, for integer, people may like to put a 0, you know, something like that. Yeah. Yeah. But here, this way, the value you put there, capital N, U, L, L. This value, if you put it in the field, this is letters. This word is treated the capital. Okay, for the this word is treated as a special value, right? Special value. And remember, there is no quotes around it. Yeah, no quotes around it. Yeah, yeah. If you put a single quote around it or double quotes, yeah, if you put a pair of quotes around it, then it's not a special value, okay? It's not special. This is a normal string value. And this is a special value. Okay? No quotes around it. No. Then, for this special value, there are many different consequences related to the special value. The query behavior, there are several different query behaviors related to the special value. Okay? Yeah, so we need to understand. Yeah. So because we need to, I need to use several slides to understand the special value. Why use null instead of some special value? Here we need to answer that question, right? Because it looks like we can do it that way, right? But if you're doing that way, yeah, sometimes you get around the situation, but there is some difference, some key difference. These two ways, there some key difference. Yeah, here, let me explain. Yeah. First, this null value, there is important objective, this null value, the purpose of this null value. Make users aware of it, because it's a special value. You need to be aware of it. Okay. For this is a normal value, okay? This value we treat as a normal value. Normal value, nothing happens, no warning, yeah. No alert, no warning. Null value, every time when you deal with a null value, there is some warning, alert, some special way that will remind you need to fix this problem, okay? Because this is special, its behavior is special. You need to pay attention to it. Yeah. You need to fix it as soon as possible, okay? Yeah, something is not quite right. Yeah. Yeah. Things like that. But normal value, you don't have that special behavior to give you a signal. Yeah, you need to do something. That's the key difference. All right? Yeah. All right. The DBMS treats it differently from other values. When you do queries, the query behaviors will be different. When you do comparisons, the comparison results will be different. Yeah. Remember last time I mentioned that 3-value logic. You need to add the third value in the Boolean values. Yeah, Boolean we know, people always use two different values, true, false. Due to this special value, you need to add a third one, unknown Boolean value. In SQL, unknown Boolean value. Yeah. All right? Yeah. Yeah. Handling null value in DBMS. Yeah. Now let's look at some detailed ways. Yeah. Who determines the meaning of null? Yeah. Null may have several different meanings. Yeah. DBMS cannot decide what's the specific meaning of the null value. Yeah. Only people who are familiar with the business, they know the specific meaning. Okay? DBMS does not know. DBMS is not that smart. Okay? Yeah. All right. So now SQL, yeah. SQL cannot do that. Now DBMS, yeah. People who are familiar with the business rules, yeah. They can explain why people use the null value here. Okay? All right. Different individual null values. Yeah. So here, the thing is, because the null value can appear in several different places, right? Yeah. Yeah. For different people in the table, yeah. So let's say both employees, their first names are not available at this time. Okay? So both you see null value. Null, that one, null, another. Two employees, both null values. Here we need to look at different individual null values. Yeah. Yeah. Why you have that? Yeah. What's the special rules to handle that situation? Yeah. Each individual null value is considered to be different from every other null value by DBMS. Different. Yeah. Consider to be different. Okay? Yeah. Employee 1, yeah. First name null value. Employee 2, first name also null value. But these two employees, DBMS treat these two null values, they are different values. That's the meaning. Okay? Yeah? So you can see, yeah. Although the appearance the same, NULL, yeah, but DBMS does not treat them as the same value. Yeah. Otherwise, you'll mess up, right? Yeah, because in real world situation, the percentage that these two employees have different first name is very high, extremely high. Okay? The percentage that these two employees have the same first name, yeah, not zero, but relatively low. Okay? Yeah, relatively low. All right. The comparison logic is different. Yeah, yeah. When you compare, yeah, the field values, when the null value is involved, yeah, so then DBMS needs to use some special way to show you the comparison results. Yeah. All right. So then, how to make the difference? Yeah. So here there is an is operator and an equal operator. Okay? Yeah. If you use equal operator, yeah, because usually when we compare value, if value equals null or not, equal operator, then this rule is applied. Yeah? Because different individual value, yeah, treated as different. Okay? Yeah. So let me explain. Yeah. What's the meaning? So here we consider employee 1. Okay? 1's first name. Null. Okay? And employee 2's first name also null. Okay? All right. And so then you may, in your condition, in your where clause, right? Where clause, we specify the condition. Then we compare, because if we use our company database, right? Yeah, first name, we use F name. F name, if we use the equal sign to compare this null value, all right? Yeah. So then, because when you go through the employee table, you know, this is null value is used to replace the F name, and that one also used to replace the F name. But no matter which one you use here, the result is false. Because that null value is treated as different from this null value. Okay? Treated, yeah, because of this rule, all right? It is considered to be different from every other null value by DBMS, by this rule. Treat as different, yeah? Because it's very risky if you treat as the same value. Very risky. Yeah. Because finally, we can think about if after some time the value is resolved for the first name, then suddenly the result will be different. Result, it cannot be null and it cannot be, or this value resolved later, but it's very likely those two values are different. So you cannot treat the same, very risky, okay? All right, for that reason, in order to get around this dilemma, then is operator is created. Because people still want to check if a value is null or not, right? But you cannot use the equal sign to check. You have to use this is operator to check. Then you get it true. Yeah. So if we replace this equal sign by is operator, then F name is null, then it's true. Yes. For employee 1, it's true. For employee 2, it's true. That's the difference. Okay? Yeah.
If first name had single quotes around it
No.
where null was not a special value,
Right.
do we then use equals instead of is if it's not a special value?
Sorry, can you?
Like if we put quotes around null
Right. No. Right.
up.
Oh, no quotes. No quotes. No
like
quotes.
In the first name assignment where it says employee's first name, the top line.
Yeah. Right. Employee first name. We know the field name is F name, right?
Oh,
Yeah.
okay.
Employee table. Yeah. Here I skipped the table. Table employee. Select employee. So where? Yeah. Because here because it's too long. So I only focus on the where clause. Yeah. Where clause. Right. Yeah. Don't put the quotes around the field name, because when you put quotes, you treat it as data. But here it's not data, right? Yeah, field name, table name. Yeah, we use backtick, but not quotes. Okay, not quotes. So yeah. You can use backtick, but you do not use quotes. Okay, yeah. Quotes you treat as data. Yeah, but it's not data. Okay, you treat the literal. When you put quotes around, that's the literal F name. Then completely different. Yeah. The meaning is completely different. Yeah. All right. Yeah. Right. So special. Right. So yeah, here the operator. Yeah. All right. B.3, other data types. Yeah. Yeah. Because later we need to talk about the 3-value logic later. Yeah. So here we just we need to look at the general thing. All right, yeah. Oh, sorry. Yeah. Oh, yeah. Okay. Yeah. Boolean data type. Yeah. Boolean data type. Yeah. So you have the third value unknown. Yeah. Third unknown. Yeah. So we need to understand this unknown value. So there is some added complexity here. Yeah. When you come, yeah. So you need to change from your own experience. Yeah, because of this one. Yeah. So later I will explain using some examples to explain the difference of this unknown value. Yeah. All right. So data type. Yeah. So we saw it before. Yeah. So the SQL standard. Yeah. International standard. Yeah. All countries must support this format. Okay. Yeah. All right. And time data type, yeah, other than the date data type, the time, yeah, so that's the normal way. Yeah. Double digit hour, double digit minutes, yeah, so seconds, yeah, yeah, all right, yeah, yeah. But also people combine these two, yeah, because sometimes you want to store the time information, including the date information, and including the time information, both, right? Yeah. So then you need to combine these two. Combine these two, remember you put a space between them, okay? Yeah. 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 So these two string formats, you need to put one string to one space character to separate. Yeah. So that it is the form. All right. B.4, compare values. Now we need to, do general comparison. Equal operator comparison for exact. Yeah. No order for comparison field is required. Yeah. So here, yeah, yeah, for exact match. Yeah. No order, less than or greater than. Order, less than, greater than. That's for the order information. Okay? Equal sign for match information. So they are different. Yeah. Because the order, this case, you require some order in the data. Yeah.
STME order? What does that word say? Some order? Or?
Yeah, some order. Yeah. Yeah. Because the order, our usual order, less than, greater than, our usual order, that order, there is a meaning called a total order and a partial order. Okay? Total order and a partial order. All right. Most of the time, we have this total order case. What's the total order? Any two values in the domain, yeah, because when you talk about order, you consider data in certain domain, right? Integer, floating point, string, data, date, time, So there is some domain, data domain of the data. In that domain, total order means every two pieces of data, when you compare, you can get order, okay? One is greater than the other or equal and so on. Yeah. That's the total order. Partial order, that means sometimes you can have the order relationship, sometimes you don't have the order relationship. Okay? The order is not defined. Okay? So this case is rare. Rare, but it happens. It exists. Rare. Yeah. Why? Because here I can give you a simple example. The order may not be defined. Okay? All right. Remember, we can store binary data in a table, right? Think about that. We can store binary data in a table. When you store binary data, when you compare two pieces of data, they're both binary. What's the order? Right? So it's hard to define because the order is not defined. You cannot define the order. Yeah. So something could happen. Yeah. Yeah. So that's why sometimes the order is not defined. Yeah. So that's why here I say, no order for this statement, it means even if the order is not defined, equal sign can still do the comparison and see if two pieces of data are exactly the same or not, right? You don't need order, right? You want to check if they are exactly the same. Can we compare two binary pieces of data to see if they are exactly the same? Yes, right? Yeah. Binary symbol by symbol, yeah, we can still, check if they are the same or not. Yeah, yeah, yeah. Because for the binary data, it could be very complicated. Yeah, because some people may argue people can use the ASCII values, right? Things like that. Yeah, but for some symbols, it does not have the ASCII value. No, yeah, some symbol, could be very, very special. Yeah. Yeah. So binary case too complicated. Yeah. All right. Yeah, without the definition for the field, yeah, it still works for this operator. Yeah. The less than, greater than comparison, yeah, to get all the information between two values. Yeah, yeah, yeah. But in our real world situation, actually, yeah, so that's why I put a rare here, yeah, because most of the time we do not need to deal with the partial order. Yeah. But here I may like to, because this partial order is a concept in math. In math, there is a partial order concept. Because math, you need to compare two objects, right? Yeah. So then, this concept can also appear in other fields. Yeah. Here, in computer science, so there is a graph theory, right? A graph theory case. Here I can use a graph theory example to explain this partial order concept. Yeah. Graph theory, that's computer science. Okay? It's not math. Yeah. Or some people also treat as related to math. Yeah. All right. So in graph theory, we can define order with respect to a graph, right? Given a graph, we can define order. Yeah? Yeah. So that's important in graph theory. Because the order, so when we traverse a graph, some order information is important in graph theory. So here I draw a simple graph. Yeah. Directed graph. Yeah. So each edge is an arrow. So there is a direction. Okay. Yeah. Point A, from point A to point B, the edge is this direction. Okay. One-way street. This arrow, this edge with direction, corresponding to the real world case one-way street. That from A to C, yeah, this direction. Okay? Yeah. All right. Then from B to D, the edge. From C to D, the edge. Yeah. Then we can define the order. If A greater than B, we mean there is a directed edge from A to B. Okay? If A greater than C, there is a directed edge from A to C. Okay? Yeah. C greater than D, because there is a directed edge from C to D. And similarly, B greater than D. Right? But the question is, when you compare B and C, which one is greater, which one is smaller? You don't have the information, right? because there is no edge from B to C, and then there is no edge from C to B, so you don't know which one is larger, which one is smaller. Yeah. So this kind of order definition, so we call it a partial order. It's not a total order. Yeah. All right? Yeah. So that is for the concept, this partial order concept. Yeah. All right. Yeah. Yeah. So order, yeah, because when you apply these two operators, then you need to make sure there is order definition in your data. Okay. Otherwise, you cannot do that. Yeah. Yeah. All right. But here, I just give you the, the high-level concept description. In your real-world situation, you don't worry about that, right? Because most of the time, we just work on the data with total order. Yeah. So we never worry about this. Yeah. All right. Compare values for individual data types. Yeah. Yeah. Numerical value type. Yeah. So here, numerical, yeah, everybody knows how to compare, right? Yeah. One value is greater than the other. Yeah. So I do not need to explain anything. Yeah. All right. Use the natural value order, numerical value. Yeah. Integer, floating point, natural value. Okay, order. Character string data type. Now string. Yeah, so let's say, character we treat as a special string. Okay, yeah. So here let's consider for the string comparison. How do we define the order for string comparison? Yeah. And it's very common. People need to compare string values. Yeah. Use the alphabetic order. Yeah. Alphabetic order. Okay? Yeah. So you know that how to compare the data with alphabetic order, right? Yeah. And sometimes people also call this alphabetic order dictionary order, because when you look up a word in a dictionary, you use alphabetic order, right? Dictionary order. Yeah, same thing. Okay? Yeah. When a string value happens to be a number, then, yeah. So I think I do not need to explain the alphabetic order, but here I need to show you some special case. You may get confused. Yeah, many people may get confused. That is this case. When a string value happens to be a number, do not get confused with these two orders. Now I need to explain this special case. Yeah. What do you mean string value happen to be numbers? Yeah. All right. For example, yeah, we have a string like this. Single quote. 1, 2, 3. It is a string, right? It's a string value. But all the characters are digit characters. Yeah. So here, you should not confuse this string value with that number value. Okay? Yeah. Because you may get confused. All right? So here, if we compare, yeah. All right. So here I just use the verses. Yeah. Single quotes 1, 2, 3. If we compare with single quotes 5, 7, yeah. Which one is larger? Okay. Single quotes 1, 2, 3. We compare single quotes 5, 7. Which one do you feel should be larger? Yeah, 57. Because we use the alphabetic order. 5, first we compare 1 and 5. Okay? 5 is greater than 1. That we are done. Yeah. Dictionary order, right? Yeah. And we compare the second character and so on. Yeah. All right. Yeah. So when you see single quotes around, remember, you treat as a string value. Okay? Even the number, you treat as string value in comparison. If number if the number value, we should not use single quotes around it. Okay? Yeah. So when you read, because when I give you homework assignment or test questions, yeah, the single quotes are not, that's important. Because our interpretation will be different. Our rules will be different. All right? Yeah. So you may use the wrong rule. Yeah. Okay. Yeah. So this is an example. Yeah. And another thing, yeah, because other than this comparison related to, so you may feel, okay, yeah, some students may feel. So ask this question: why people treat 1, 2, 3 as string value, right? Why you put a pair of quotes around a number, right? Yeah. In the real world situation, this happens frequently. In the real world situation, this happens frequently. In the real world, when you have numbers, but they appear as the string data type, not appear as the number data type. You have the situation. Yeah. So why? Oh, all right. In our class, at the same time, we do some simple web applications, right? Yeah. In our class, at the same time, we need to do some web applications. All right. And in web applications, all right, think about how to collect the data from the users. Yeah. Right? Because we ask user to enter the user's information. User need to enter user information, right? Yeah. And from our data processing side, we need to retrieve the information, or we need to collect. We need to, get the information from the users there. We need to do data processing. Yeah. 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 So here, there is a rule. All the data from a web page collected, yeah. Yeah. Here I just from a web page is treated as string data. Okay? String data by default. Okay? Yeah. Whatever it is, yeah, it is treated as string data when you collect from web page. Even numbers, yeah, whatever that numbers, yeah, yeah, yeah. So that's the basic rule. Okay? Yeah. Because when you send the data, so all the data is treated as string data. Yeah. At the receiving side, after you receive the data, their purpose is not for the string value. The purpose, they should be used as numerical values. You need to do conversion. You always need to, yeah. So based on your understanding, so this particular piece of data should be a numerical value. Then you have to do conversion. So in Java, you have to apply data passing methods. Certain data passing method to do data conversion before you can do the calculation. Okay? Yeah. You assume it's a string data. So then you do data conversion. Yeah. So in JavaScript, remember we use that special method parse int, right? Yeah. In JavaScript, okay? Yeah, JavaScript parse int. Yeah. You need to do conversion. Yeah. Before conversion, it's a string data. Okay, so you have to do conversion, convert it to integer number. Then you can do arithmetic operation. Otherwise, the operation will be interpret as string operation, okay? Not an arithmetic operation. You do string operation, okay? Think about it. Because some people may forget this. Yeah, forget this step. Yeah. All right. Because they treat, I entered numerical value. I entered 1 in the first field. Then I entered 2 in the second field. Yeah. Because they just added these two numbers directly, right? And they forget to do conversion. Yeah. If you do that, you will, because the string, you do concatenation. It's not an arithmetic operation. 1 plus 2 equals 3. It's a string concatenation. All right? Yeah. Yeah. So that's important. Okay? Yeah. So here, this is the second time I talk about this issue. Okay? Yeah. Before I mentioned once before. This is the second time. Yeah. All right, next. Date, time, data types. Yeah, we can still do comparison. Yeah. The comparison is for less than comparison, the earlier date is considered to be smaller than the later date. Okay? The data value. Yeah. Earlier, smaller, late, larger, that order. Okay? Yeah. Yeah. So this sometimes you need to, take your time. Not like when you compare numerical values, you do not need to, just use your natural way. Yeah. But for the orders, sometimes you need to, which one, yeah. So you need to think about it. Yeah. Get used to this special order definition. Yeah. All right. Properties for the values of character string data type. Yeah. Literal string value. Yeah. All right. It's case sensitive. Okay. Yeah. Because the ASCII code, capital case, lowercase, they have different ASCII code. Yeah. Number. Okay. Yeah. Different. So treat case sensitive. Yeah. Placed between single quote. Yeah. And yeah. So this is the SQL standard. Yeah. Some students still ask me, single quotes. Single quotes. This is SQL standard. All right? Yeah. But sometimes people use the double quotes. Double quotes supported in MySQL. Yeah. And other data DBMSs, but it can vary, right? But it is not a standard. Yeah. It's not standard. So it's not guaranteed. Okay? It's not guaranteed. Yeah. If it's a standard, then it is guaranteed. Okay? You can use it everywhere. Yeah. But it's not standard. Sometimes it works, sometimes it doesn't work. Because it's not standard. Okay? Yeah. Yeah. Then, because for fixed length string, yeah, so there's some rule. Yeah? Because think about this case. Yeah. Remember, sometimes when we define data type, we require fixed number of characters, right? Yeah, for a particular field. Yeah, fixed number of characters. Yeah, certain number of so fixed. But so here 4 characters. If a user enter 2 characters, do you accept it or not? Right? Do you want to reject it or accept it? Right? So that's the question. If you want to reject it, then waste a lot of time, right? Yeah. Every time you reject it, then you find a way to fix it. Yeah. So then the DBMS, you apply a special rule to do the conversion. Yeah. The conversion is padded the blank characters. Yeah, blank. Yeah. Yeah. If 2 characters, then pack 2 blank characters to the right for the shorter string. So if it's 2 regular, then add 2 more blank characters. So you get 4 characters. Then it becomes, follow the rule, right? Yeah. Can you explain why this rule used here packed 2 blank characters to the right, not to the left? There is some reason. To the right, but not to the left. Can you see some simple reason behind it? To the left, to the right. Yeah. Related to the alphabetic order. When you compare 2 strings, alphabetical, the leftmost character is the most significant one, right? You start from there. Yeah. Here, if you pack to the left, you change the order significantly. Okay? So you don't want to make a big change in the order. You pack it to the right there because you can compare the most significant character first, second, then the least significant, right? So the 2 blank characters, you pack them at the least significant position. Yeah? Then the impact, you reduce the impact to the smallest. Otherwise, you put too much impact. Okay? Yeah. You change the order, big time, right? Yeah. You don't want to do that. Yeah. All right. Here you can see. Yeah. Every rule, there is some special reason for it. Yeah. For comparison purposes, strings are considered ordered. Yeah. So we already. Yeah. So there is also concatenation. In SQL, the concatenation operator, it's not a plus. Double vertical bar. That's the concatenation in SQL. Yeah. SQL, we know SQL is a very old programming language. Yeah. So the reason, because at that time, this plus sign, SQL is earlier than Java, right? Yeah. The plus sign, So we know C++ also used that. Java, that's after, way after the SQL, the history. Yeah. SQL much earlier than that. Yeah. So the rules are different. Yeah. All right. So that's the part B. Yeah. Let me see. Oh, we only have 10 minutes for part C. Yeah. But we don't want to waste 10 minutes. So let's do 1 or 2 slides in part C. All right, so part C here. Yeah. Concepts for SQL tables. Yeah. So let's look at C.1. Create a table. Yeah. If something we're already familiar, we can go a little faster. Yeah. Only when we get something new, so then we use some time to understand. Yeah. All right. Now, because the table concept, that is the most important one in the SQL, the center part, the core part. All right. The create a table, the command is simple. We saw several already. Yeah. Create a table, table name. Yeah. But after that, specify information. Yeah. New relation by giving it a name, table name. Table name there, because it's not a keyword, right? So you do not need to use the uppercase. Yeah, it's not a keyword. Table name, field name. So uppercase, lowercase. Yeah, so you can use. Yeah. All right. Attributes. Yeah. Format. You need to specify the name, attribute name. Okay. Then attribute data type. Then constraints. Yeah. So there are some simple constraints. So when you describe the attribute, so you can add relatively simple constraints. Yeah, some constraints are simple. You just append at the end of the, attribute line. But some constraints relatively complex. Yeah, some constraints relatively more complex. Then you cannot append. that complex constraint, that you need to define your constraint. After you define the table, you still have a chance to add more information after you define the table. Yeah. So don't worry, if the constraint too long, too complicated, yeah, leave them out. Yeah. So just bypass the constraint. Then, after you complete the table definition, then you define those complex constraints one by one. 1, 2, 3, and so on. Yeah. All right. Constraints. Yeah. Yeah. There are several different constraints. The first one, key constraint. Yeah. So remember in our homework question, key constraint. Key constraint, the meaning key, uniqueness. The value must be unique. Yeah. You cannot have duplicate values. Yeah. If you define, how to define the key, you need to use that unique keyword. Yeah. How to define the key? You append a unique keyword at the end. Yeah. So that's the key. Uniqueness. All right. Entity integrity. Yeah. Entity. So what's the entity integrity? No primary key value can be null. Yeah. So that's the hidden rule. Okay. Hidden rule. You cannot see it, but DBMS applies this rule to check your data. No primary key value. If some value defined as a primary key, it cannot be null. Okay. Yeah. Even if without not null constraint. Yeah. Not null is a constraint. Yeah. If you do not allow a particular field to accept null value, you have to use this not null constraint if it's not a primary key. If it's a primary key, you do not need to use not null because it's supposed to be not null. Okay? Yeah. So by default, not null. If you put a not null constraint redundant, okay? It's redundant. Yeah. Not wrong. Yeah. All right. Referential integrity, foreign key. Referential. Foreign key. Yeah. So in one table, I showed you before. Yeah. But because later we have one separate topic, we need to study this foreign key, the whole thing. Yeah. So here we do not need to talk about that. Yeah. So because it's a relatively big topic, foreign key topic. Yeah. We need to understand much more. Yeah. All right. Alternate way to add constraint. Yeah. Alternate way, just as I mentioned, some constraint relatively long, relatively complex. Then we need to use some alternate way to add and define those constraints. Yeah. How to do that alternate way? So after table is created, then we can write a separate SQL command. The command is alter table, then command. So what's the constraint? Remaining part. Yeah. You need to give a constraint name. Yeah. When you define a constraint, you need to give a name. Then after the name, then you need to specify your constraint rule, the rule for the constraint. Yeah.
It's not optional, it's required. Is it required to specify the constraints? Or is it optional to define?
Optional. Yeah, optional.
It's
yeah.
optional.
Right. When you need it, you use that. Yeah, it's not. If you do not need it, not necessary. Yeah.
Oh.
Yeah. We will see some examples. Yeah. Today, let me know. Yeah. Because later we will see some examples. Yeah. Let me see if I have time. So this is our last slide. I think I can use 2 or 3 minutes to complete that. Employee table of company database. Yeah. This is so you can see in this one, job table if exists. Yeah. So I remember I explained this before. Yeah. This line is very useful at the database design stage. Yeah. And database design stage, because you need to change the table structure frequently, right? Yeah. Every time when you change, the best way is you drop that table. Then you create a new, create a new table. That is much faster than you modify the table, okay? You change here, there, several places, yeah, much slower. If you drop the table, then you define a new table, that's the fastest way. At database design stage, okay? Yeah. So that's why people use this line frequently. Job table if exists, employee. Yeah. If it does not exist, then you skip this command, okay? So then you create table, yeah, so there. Yeah. Here you can see the format, yeah, the field name, then the data type, yeah, we know the meaning, right? I explained before. Yeah. Then, after that constraint, not null constraint, default, null, yeah, default clause. Okay, later we will understand this default clause. Yeah, all right, yeah, so default, yeah, so we will have more understanding. Yeah, all right, so that, okay, yeah, all right. Yeah. Here you can see we do not have the primary key definition. Okay, yeah, yeah. Primary key, you can see alter table employee add primary. So this is primary key constraint. Okay, add a primary key SSN field. That's the primary key. Okay, all right, yeah, yeah. But sometimes, yeah. So this is one special way. Many times people just add a primary key line at the end. Okay, primary key line at the end. Yeah, later we will see that. Primary key clause. Then you just put an SSN. Much faster, right? Yeah. At the end. The last line. Yeah. Yeah. Okay? Yeah. Yeah. So later. Yeah. Yeah, but the reason here we use this alter, because when I export the database, yeah, the export, yeah, so the MySQL export, when you do the export, it will use this way to define the primary key, okay? It does not use the primary key clause way to define, okay? Yeah. So use this way, so that's the reason, yeah. All right, so that's it. Yeah, we just get started. But next time we will do this part C. We will complete this part C. Yeah.
So, like, key is not defined. Is there like a default key you would use, or is there just
no
key?
Just no. No. Yeah. There is no default. You have to explicitly define it. Otherwise, yeah, because it is allowed for a table without primary key, right? Yeah, you cannot assume every table must have a primary key. No, you cannot. Okay, yeah. So that's why no default primary key, no default any key, no default any key. Okay, yeah, yeah. All right, that's it.